Okay, here we go. So this is one of my favorite names in all of math. It's called a radical. That's a pretty cool name, or a pretty radical name, right, kids? Do you know what radical means, other than awesome? Huh?
It's from the 80s.
Yes, the best time, the 80s. Only two good things to come out of the 80s, me and Nintendo. What's a radical?
How do people on the print board of games? I don't know.
You've definitely seen one. You just might not have heard it called a radical before. Oh, all right, here it is. Here's an example. There's a radical. It's awesome. You've probably not heard this referred to as a radical. When you see that symbol or that problem, what do you think? It's a square root. You probably think of it as a square root. And this is a square root, but that's not the only kind of radicals there are, as we will discuss in a little bit. This is a square root because the question that we're asking is what number, when you multiply it by itself, gives us 49? And the answer is 7. Because 7 multiplied by 7, or 7 squared, is equal to 49. That's why it's called the square root. What number squared is 49? Okay? Check this out. What is it?
0.
It's 0. 0 times 0 is 0. Perfect. And I don't want you to think we're going to leave the fractions out in the cold. No, sir. Fractions are people too. The way that you break down a fraction that is inside of a radical, in this case a square root, is real simple. You square root the numerator and you square root the denominator separately. So the square root of 16 is 4, and the square root of 81 is 9. So the answer there is 4/9.
Oh.
Cool. And if we're doing fractions, I think we might as well make the whole thing complete and toss in a decimal too there. What do you think?
8.
Yeah, 8 is 64, but this is not 64. This is 0.64. So instead of 8, it will be, how about just 0.8?
0.8. Okay.
0.64, the square root is 0.8. Okay, so let's see. We did whole numbers, we did 0, we did fractions, we did decimals. How about some variables? Or did you really just groan at variables? Variables in algebra? What is happening? This one's a little bit trickier because you have to recall that the rule for variables is when you multiply two things with exponents together, you add the exponents. Okay, so I'm just going to tell you what the answer to this one is. It's x to the 4th. So let's talk about why it's x to the 4th. If I took x to the 4th and squared it, which is what I'm doing here, square root means what thing squared equals x to the 8th. You may recall that when you have a base raised to a power that you multiply the two powers. 4 times 2 is 8.
Mm-hmm.
If you don't recall that, you should recall that when you have two things with an exponent multiplied together, you add the exponents. 4 plus 4 equals 8. So, somewhat unusually, these square root problems or radical problems with variables are the easiest because if you take the square root, what's a quick way to get to the 4th power? You just divide by 2. 8 divided by 2 is 4. So with that in mind, what do you suppose the square root of y to the 6th is? Y to the 3rd. Yeah, 6 divided by 2. Y to the 3rd times y to the 3rd is y to the 6th. Now let's see if we can really bake your noodle. Let's toss a bunch of stuff together. How about this? Now don't freak out just because we've got a variable along with a constant. This one's done in the same way that the division problems were done, which is that you separate them. Square root of 9, we'll do that one, and we'll multiply by the square root of x to the 12th power. Okay, square root of 9 is 3, and square root of x to the 12th is, there you go, x to the 6th. Shazam, as the kids say. All right. Okay, I'm going to give you 2 more of these, and I'm just going to warn you right off the bat, they're going to really make you mad. What do you think? If you had to guess, and you do because I haven't taught you how to do it, if you had to guess, what would you say?
-6.
-6 is a fantastic answer. So fantastic that that actually is the answer. Now here's why. We're taking the square root of 36, which is 6, and then we're multiplying it by the -1 that is out here in front. If there's no number, we use 1 as usual. So this is -1 times the square root of 36. -6, you're right. Okay, here's why this is going to make you mad. The answer to this one is not -6. Why is the answer to that one not -6? Exactly right. You might be tempted to say that's -6, but -6 squared means -6 times -6, which is positive 36. The only way you can multiply 2 numbers together and get -36 is if one of those numbers is positive and one of those numbers is negative. But if one's positive and one's negative, they aren't the same number. Now you may be tempted then to say, well, you can't answer this question then. And for now, that's the correct answer. But we're not going to say there's no answer or does not exist. We're going to say it's not a real number. I have hinted at this before, but when you write not a real number, I think your immediate thought should be, does that mean there are fake numbers? And the answer is, yep. They're called imaginary numbers, and we're going to do them in not too much longer. In not too much longer, you will never have to write not a real number again, because we're actually going to figure out what the number is. It's very exciting, right? Won't it be exciting to not have to write the incredibly easy answer, not a real number, and be able to do some insanely difficult math to get an actual answer? I'm excited. Who's with me? No? Yes? No? Remember? Okay. So, let me show you some that don't work out quite as nicely. That one does not work out quite as nicely. How come? Because it doesn't what?
It doesn't have 2 numbers that are the same.
It doesn't?
Um,
Oh, I think it does. I think it does have 2 numbers that are the same.
Say again?
She said there's not 2 numbers that are the same that will multiply to get 45, and I disagree. There are 2 numbers that will do that. They're just not nice numbers.
22.5.
They're not whole number. Okay, 22.5 is if you divide by 2. That's not if you square root it.
Oh, okay.
So I'm going to show you how to do this on your calculator. Okay, so first I'm going to show you how to do it using your school-approved super calculator. Can I see that, please? This is the official class you already put the answer on there. Don't do that. Okay. So here's the incredibly high-powered Casio FX55 Plus, and the square root button is right there. See, it's got the square root with a little box. So if you press square root and then type in 45, it's really dark, it's really difficult to see. Square root and then 45.
mine's a little wider.
You can kind of see that. Oh, there we
There
go.
you go.
Perfect. 6.708 is the answer. 6.708. We're just going to round it. Here you go. Thank you.
Mhm.
Your iPhone also.
Yeah, now I want to show you how to do it on the device you actually have, which is your iPhone. If you didn't know, when you open up your calculator, normally it looks like this, and if you turn it sideways, it has a scientific calculator. If you don't have an iPhone, this works with the Android operating system as well. If you turn it sideways, you get a scientific calculator. but I don't have an Android phone because I love and respect myself. So the way that you do it on an iPhone is you type in the number you want to take the square root of, which is 45, and then right here it's got a little 2 square root x, and when you push that button, 6.708. So under normal circumstances, you can just find the square root of a number, but when you get something weird like 45 that doesn't have a nice square root, sometimes we need the calculator to bail us out, and so we'll use the calculator in those cases.
So on the calculator, you do the rational symbol and then the number, but on the iPhone, you would do the number and then the symbol.
Right, on your phone, you do the number and then the square root symbol. Actually, I never tried it the other way. I don't know if it works or not. Let's try it. If I do square root 45. Oh, yeah, you can do it that way too. Square root 45 equals. Yep, that works also. I've never tried it that way. Cool. Thank you, Steve Jobs. Go ahead.
When you're doing the test and stuff, is there a certain point after the decimal that it wants us to stop at?
3 places after the decimal is pretty good. If it wants something besides 3 places, it'll say like round to the nearest 10th or the nearest 10,000th or whatever. Okay, so that's square roots. That's not too bad. I feel like we can handle that. But I told you radicals aren't all square roots. So let me show you one that's not a square root. This is called a cube root. This question is saying, what number, when I cube it, gives me 1? What number multiplied by itself 3 times is 1? And the answer is 1, because 1 to the 3rd power, or 1 times 1 times 1, is 1. Great. Okay, now I know the negative problem made you mad earlier, because you can't do the square root of a negative. This is going to make you even more mad, because you can take the square root of that. I mean, not the square root, sorry. You can take the cubed root of that. What number, when I multiply it by itself 3 times, gives me negative 64? Negative 4. And here's why that works. Let me show you the reason it works down below. Negative 4 cubed is negative 4 times negative 4 times negative 4. A negative times a negative is a positive. That's positive 16 times negative 4. And negative 16 times negative 4 is negative 64. So multiplying a negative by a negative gives you a positive. Multiplying a negative times a negative times a negative gives you a negative. What do you think would happen if I raised a negative to the 4th power? What kind of answer would I get? A positive. What about if I raise the negative to the 5th power? A negative. What about if I raised it to the 23rd power?
But what?
If I did a negative number to the 23rd power.
So odd, so probably negative.
Oh, I love what you said. He said it's an odd power, so your answer is going to be negative, and that's exactly right. If you raise to an even power, your answer will be positive. And if you raise to an odd power, your answer will be negative. All right, let's try everybody's favorite. So cubed root of 8 and cubed root of 125 both work out very nicely. Those are both whole numbers. You do it just like with the square root, which is cubed over cubed. The cubed root of 8 is not bad. It's 2. 2 times 2 times 2 is 8. Now, when you get to cubed root of 125, you may not know the cubed root of 125 off the top of your head. But your calculator, I don't want you to think it's only useful for decimals. You can do cubed root. It's right there next to the square root button. It's got the little 3 for cubed root. Cubed root 125 is 5. So if you're ever in a pinch and you're like, I don't know what the cube root of 125 is, the calculator can bail you out. Just don't let anybody see you do it, because it'll be really embarrassing at the math parties. They're like, use a calculator for cubed roots? You're not invited.
On the calculator,
You don't get a
there's
turn on the
cube
slip
root
and slide in the backyard.
On mine, I have to do shift, and it's one of the extra functions of one of the existing.
This
methods.
doesn't have a shift. Oh, yeah, it does. I can't do it.
You can do it on that one.
You can do it. You just have to believe in
It
yourself.
says math error.
All right, hold on 1 second. I'll take a look. What do you think happens there? Now, when it was a square root, what did we do?
You just used it.
We divided it the power by 2, exactly right. So what do you suppose happens? You divide it by 3. 6 divided by 3 is? So x squared, exactly right. Very good job. Okay, let's do one more of these. Let's combine it all. You know, if cubed root exists on this calculator, I don't know how to do it. Guess you're just gonna have to do it like a real man using your noodle. All right, what do you got? Cubed root of negative 27 would go first. Yep, and then the cubed root of x to the 9th. That's negative 3 times
3.
x to the 3rd. And there it is. Hey, that's not bad at all. Huh, yet. You guys are so negative. How about that's not bad at all, and I'm a math champion? Little positivity here. I'm sure they won't get any harder than that. Everything's going to be fun. Just calm down.
Yeah, you know what? Quit saying that.
Okay. What do you suppose that one's called?
Insanity.
Insanity is not the answer we were looking for. Fourth root? That is. What number raised to the 4th power is 81? 3. Because 3 to the 4th is equal to 81. Now, I don't know if your standard scientific calculator will do the 4th root, but I know that your phone will.
Yes, my calculator.
So on your phone, the 4th root is right next to the cubed root. On an iPhone, it's y root x.
Mm-hmm.
The y can be whatever power you want, which is useful because I'm about to give you a 5th root one here in a second. So what you do is you type in the thing you want to take the root of, which in this problem was 81. So we do 81. Then you type that y root x button, and then you press the number of roots you want to take. Here it's the 4th root, so I'm going to do 4 equals, and there's my 3.
Oh, okay.
Huh? How about that one? What's that called? That's called a 5th root. So if there's a way to put a negative into an iPhone calculator, I don't know what it is. So one thing that you can do, we know that our answer is going to be negative because that's the only way you can get a negative inside. We could do the 5th root of 243. So 243, press that special y root x button and do the 5th root. So the 5th root of 243 is 3, which means the 5th root of negative 243 is going to be negative 3. I don't know if it's even possible.
It's the minus sign.
Yeah, but if you just type the minus sign, it doesn't make it negative. Oh, here's a little worker. I don't know if this is probably more trouble than it's worth. But if you do 0 minus 243, that gives you negative 243. And then press the root button and do the 5th root, get negative 3. That's probably more trouble than it's worth. So I think if you just do minus 243, does anything happen? You got to do equals. Minus 243 equals will give you negative 243. Then press the y root x button and the 5.
There's a little thing by clear, and it's negative,
Oh,
positive,
it's right there.
Oh, so I can do 243 and then tap the
Yeah,
negative
that's
button?
the
Oh, that's
thing,
cool. Oh, you learn something new every day. I mean, I don't appreciate you showing me up in front of all my YouTube subscribers right now, but I mean, you learn something there. That little plus minus button up there will make it a negative. That is a much better way of doing the problem. Unfortunately, you did correct the teacher on the internet, so you do fail for the year. Sorry about that. I don't make the rules. Okay, how about this one? Oops.
Wait, we can solve that one right now, right?
You can't? Why not?
As even numbers?
Yeah, I would have to, the answer to this would have to be negative because that's the only way you can get a negative inside the root, but I can't be negative if it's an even root.
Yeah, technically.
Negative, like 3 to the 4th power is 81. Negative 3 to the 4th power is also positive 81. So what's the answer to this one? Not a real number. It's one of those dang imaginary numbers.
So it can't be negative if
If it's a
Yeah,
square root.
actually, not that this is relevant to your life in any way, but if you're curious, when it's on the outside like this, it's called the index. That's the name of that number, the index. It's not really called a root, but if you call it the index, I feel like that'd confuse people. If you say root, we know what you're talking about. But index is the final Jeopardy
And it's not
answer.
number y.
Because you cannot take an even root of a negative number. When it was the 5th root of a negative, totally fine. Same thing for the cubed root of a negative or the 7th root of a negative or whatever.
You cannot take an even.
An even root of a negative. Not to be confused with even root, the outboard motor company.
Taking it.
Okay, I'm willing to admit that was a pretty niche joke about the outboard motors. That's for the 3 boating fans out there. 3 might be an exaggeration. So this one, just like all the rest, you split it apart. Cubed root of 64 times the cubed root of x cubed. Treat it like it's 2 different things. Cubed root of 64 is 4. Cubed root of x cubed is x. 3 divided by 3 is 1, so x to the 1st power. And this is how we do it. Hey, that seems all right. And I don't see anybody crying about things yet, so we're going to keep going.
No, Wassinger's not here.
We do math until somebody cries. And then we keep on going. Okay, so one of the little shortcuts that is handy for you to know is that square root and squared are the opposite of each other. Square root and squared exactly cancel out, okay? Let me give you, I'll write a little thing over to the side to prove it. What's the square root of 25? 5, okay. What's the square root of 5 squared? Well, 5 squared is 25, right?
25.
So what's the square root of 5 squared? Also 5, because 5 squared is 25. Square root and squared cancel out, where I'm left with just 5. So in this problem, the square root and the squared are going to cancel out, which might make you think that the answer is negative 3. How come the answer is not negative 3? Yeah, your answer to a square root problem can't be a negative. So what do we do about this? We just take the absolute value. And the answer is positive 3, because the answer to a square root problem always has to be positive. Now that seems kind of silly. Why would we not just do negative 3 squared and get 9 and then go on with our lives? Well, here's why. What's the square root of x squared? It's x because they cancel each other out exactly, right? Squared and square root cancel each other. But I have to specify that whatever x is, it must be a positive number. The solution has to be positive. So the answer isn't x. The answer is the absolute value of x. I have to specify, because I don't know what x is. It's some number. But whatever number it is, it's got to be a positive, and absolute value tells me that. Hey, we can do this with fourth roots. Who's in? I do not see a show of hands. I'm going to assume that's because you're busy writing. Otherwise, you'd be waving your hand and cheering when I said who's with me. What do you got here? The fourth root and fourth power cancel each other out. So the answer is x minus 2. But I have to specify that whatever it is must be positive, so absolute value of x minus 2.
Equals 2.
Mm-hmm. Okay, here's a goofy one. I mean, not that they haven't all been goofy, but here's a goofy one. So I'm going to separate these like I have for all of the square roots. So square root of 25 times the square root of x squared. Now here's why this is goofy. The square root of 25 is 5. I don't have to put absolute value marks on that because 5's positive. The square root of x squared is x, and I do have to put absolute value marks on that because I don't know what x is. I know it's a number, but I don't know what the number is, so I must specify x is a positive number. That's a little tricky. I confess that's a little tricky, but that is the worst that they get. I'm just kidding. They get worse. I have not yet begun to defile myself. Here we go. This one is legitimately gross. I hope you're ready for it. Good luck, suckers! Huh? We are going to factor. I'm so happy that you saw that. Look how cool that is. That will factor perfectly. What will x squared plus 16x plus 64 factor into? It's x plus 8 times x plus 8, also known as x plus 8 squared. Uh-huh. Which means my answer is... absolute value of x plus 8. Must be in the absolute value marks because we have to specify that whatever this turns out to be, it's got to be positive. Who's ready for some graphing? I forgot to pass out graphing paper, don't
Get together.
I know what you were thinking was, this is so cool and fun, but I wish there was graphing. Well, you won't believe what I have in store for you. Who's excited? Put your hands down. Put your hands down. YouTube can't see just the forest of hands that are being waved right now in celebration. Okay. You ready? I'm ready. Let's do it. Okay, so here's the function that we're going to graph. This first function is called a parent function. It is the most basic of functions. There we go. As far as graphing goes, these aren't bad. Graphing the square root function. And the reason it's not bad to graph square root is because x can't be negative. So when I'm graphing this, I don't have to worry about any negative numbers at all. X cannot be a negative number. Okay? So when I make my chart, my T-chart that everybody loves, and I'm substituting in values for x, the lowest I ever have to go is 0. 1, 2, 3, 4. That seems good. Okay. So here's how we're going to fill in the other side of this chart. I'm going to substitute each one of these x values into the original function here. Okay, so it's square root of x. If x was 0, what's f of x? Meaning, what is f of 0, or the square root of 0? 0. Cool. What's the square root of 1? 1. What's the square root of 2? Yeah, that one's a little worse. We're gonna have to actually use our calculators here because 2 doesn't come out to be a nice number. So let's go to the calculators. Say it again.
1.414.
Okay. What is the square root of 3? Like 1.7, I think. What's the square root of 4?
2.
Right. So I've got several points here that I could graph. I feel like the 1.4 and the 1.7 I'm probably going to avoid those just because they're decimals. So let's go ahead and get the graph here. And let's plot the first couple of points. Okay, so let's do 0, 0, and then 1, 1, and then 4, 2. The only other whole number that actually will fit on here is when x is 9. Because what's the square root of 9? 3. I don't have to worry about going on the negative side because I can't have a negative x. So that, children,
Which one did you do next?
I did 9,
0,
3.
1. You did 0, 0,
I'll put that
1,
on there.
1.
I did 9, 3. I only did the whole numbers. So I did this one, this one, this one, and this one. Those are the only ones that I graphed.
Oh, right on.
Oops, covered it up. Okay, go ahead and cut this graph out. Do a little art project here. There we go. Should have made my T-chart a little smaller. Live and learn. There we go. Cool. That doesn't seem bad. I certainly can't imagine them being worse than that, that's for sure. This is the most monstrous thing I can possibly cook up, so I feel like it's all downhill from here. Right, guys?
Yeah.
All right. Challenge accepted. Let's try a cubed root one. That seems good. Who doesn't like cubed roots? And I see no hands being raised. Everyone likes cubed roots. Oops, sorry. Let's do a cubed root minus 4 just to really ruin everybody's day. Now, I know that when I graph this, I'm only going to graph the whole numbers. So when I make my T-chart, I'm going to try really hard to only pick whole numbers. Now, what I mean by that is I am only going to pick numbers that I can actually take the cubed root of and not have it be a total disaster fire. Okay? So give me a value of x that I can take the cubed root of, and it turns out nicely.
3.
Can I take the cubed root of 3?
9.
I don't. 8. 8's a good one. So f of 8 is the cubed root of 8, which is
2.
minus 4.
-2.
Oops.
I don't know.
-2. Great. Now, since this is a cubed root, it's okay for me to do negatives. Let's do -8. What's f of -8? So the cubed root of -8 is
-2.
-2 minus 4.
-6.
There we go. I don't really want to go too much higher than 8 and -8 because my graph's only a 10 by 10. So give me numbers lower than 8 that I can take the cubed root of evenly. I cannot take the cubed root of 4. I mean, I can, but it's gross.
Did you say 4?
I said 4.
Can you do 1?
I can do 1. That sounds great. Because what's the cubed root of 1? 1 minus 4?
-3.
Okay. And I bet I could do -1. What's f of -1?
-1.
Minus 4?
-5.
There we go. You're missing one really obvious one, the easiest one of them all. How about 0? What's f of 0?
0.
Yeah, cube root of 0 is 0. Minus 4?
-4.
Cool. So that seems like it's going to give me enough points to graph. My points would be 8, -2, -8, -6, 1, -3, -1, -5, and 0, -4. That seems pretty good. So on my graph, let's put them points.
Ah. I'm sorry.
Calm down.
I know.
8, there's 8, -2. There's -8, -6. Great. I'll do 1, -3, -1, -5, and then 0, -4. This is how cool this one looks. That is a cool graph. Looks kind of like a little snake. Looks like a snake that has been hit in the road. Except he's happy about it because this is awesome. There's not a better way to go. Thank you, Serpent, for giving your life in service of math. Gone but never forgotten. So that's how you graph them, and that's also a quick review of function notation, which you will need to know how to do. Okay? Does anybody have any questions about any of that stuff? No? No questions? Any cries for mercy? Pleas to the Almighty?
Is there a certain amount of points that we have to figure out before?
Oh, now that's a good question. How many points is enough points? Well, all of the square root functions look like this. It's just a matter of where they start and how high they go up. So they all have that kind of curve shape. All of the cubed root functions look like this, where they've got like this is, if you cover this up, that's the square root. And then that's like upside down square root. All the cubed roots look like that. So you need enough, like we did 5 here, and that was enough once you knew what the shape was supposed to look like. You can graph 4th roots, 5th roots, 6th roots. We just won't. Not in this class. Now you can do it at home for funsies. But in this class we won't do 4th, 5th, 6th roots. I mean, we'll do algebra and stuff with them, but we won't graph them. But you can do it for kicks. Your cable's out, you're like, man, I'm bored. Let's graph some 5th roots. Be my guest. Any other questions?